broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Thanks for joining this little presentation about Rollformer technology. So I just want to go over a few things first. I'm going to put it out there right now. I'm not a Rollformer expert by any means. However, I deal with clients using Rollformers every single day. I know a good amount about most of the popular machines out there today, and for this reason I decided to put together this little presentation because I am asked almost daily what Rollformer is best and which one should I buy. I'm not going to answer that question today because it's extremely subjective. All Rollformer technology today have positives and negatives. So the purpose of today's discussion is to impart upon you all a little bit of some the knowledge that I've been able to gather during my day-to-day. If we have time, I will answer a few questions from the audience after the presentation. So you're welcome to ask questions during the presentation using the chat feature in the webinar control panel, and you can also raise your hand. We can take some live questions afterwards, which my colleague Tanya will help me out with at the end of the presentation if we have time. If we don't have time for those questions following the webinar, I'm going to answer them all personally by email afterwards. So that being said, this discussion will be extremely impartial. In fact, I will not even mention in this presentation the names of any Rollformer manufacturers. I'm also not here to tell you that you should or shouldn't buy a Rollformer. I'm not promoting rollforming technology. This is really, I'm really assuming that you guys have made this decision at this point already. Or are looking for more information before you make that decision. So what I'll cover today are a few things I believe are important before making the decision on what to purchase. So we're going to take a look at a few things. They're on your screen now. You should be able to see them. So the technology and its purpose, basic types of rollformers and their differences, rollformer operations, the controllers, software for rollformers, and other considerations, things that I think are important to know before you go ahead and buy anything. So we'll go into the technology and the purpose. And I think most people here understand the basic purpose of a cold form steel roll forming machine. The technology itself has been around for decades, rolling and forming thin flat coil into structurally improved shapes, essentially. So steel itself has an excellent strength to weight ratio. It's fire resistant, recyclable, it's easy to work with, and it is readily available. Light gauge steel construction is quick. It doesn't require any specialty tools, and it can be adapted for both commercial and residential use. Now, while roll forming of light steel studs has been around for a long time, today, we're really going to be focusing on the smaller, more affordable machines rather than the large-scale machines used in mass production of light gauge steel studs. The purpose of these machines really is to increase productivity by decreasing panel assembly time, by using computer-aided design to accurately cut, punch, and label each member so that it can be easily assembled without the need of cutting and measuring. So this time savings in labor is how these machines intend to save your company money. So whenever I get into these types of discussions, I like to separate the available commercial machines into two main categories. They are important to understand since this will likely dictate how and what you're building, okay? We can go into a lot of different nuances in these machines, but really this is how I kind of break them up. So there's single profile machines. The simplest way to understand these machines is that you will buy a machine per profile shape. For instance, if you require a 6-inch stud, you're going to need a 6-inch stud machine. If you need a 4-inch stud, then you need another machine to roll 4-inch studs. Single profile machines typically also mean that you are using C-channel stud for both stud and track, as opposed to using a more common slip track or U-profile track. This is an important difference that you need to know. because it, you know, sometimes you need to know this depending on where you're building and what you're building. Does the design code or building code allow for this? In most cases it does, it's not a problem, but you should keep this in mind. Single profile machines are now becoming a bit more advanced, and some manufacturers even have features to allow you to run both stud and track of the same profile thickness. So it's something else to think about. Just going to take a sip of water here, guys. All right, so next is multi-profile machines. So you might have guessed, most multi-profile machines work using a typical stud and slip track construction method. Some of them also go so far as to allow you to change profiles. Typically the cost of the machine is significantly higher. However, it's definitely more versatile. The thing that many people don't consider with this type of machine is that the time cost, is the time cost involved in changing profiles. Profile changes can sometimes mean retooling, meaning you don't want to have to do this often, and this will cut productivity and ultimately decrease your final output. It almost always also means changing the spool, so the flat stock that you're using to produce these studs, and that again decreases the output because of the time it takes. So for these reasons, while a multi-profile machine is definitely more versatile and maybe less expensive than purchasing 2 or 3 machines up front, it may end up costing you more money down the line due to being less productive during those profile changes. If you know as a company you're going to always need 4-inch and 6-inch profiles, then it may be more cost effective to purchase 2 machines and have those running continuously, just pumping out studs, versus having to stop your whole production line to retool or change out a roll every time that you need to. So next we're going to get into the different types of operations included in these machines. Excuse me. Most commercial machines available today, they come with several types of operations to automate the stud and panel manufacturing process. Most companies also offer you the choice to customize these operations. So they can be so simple as to kind of change out, you know, the type of punch or slotted holes for round holes of different diameters. Or they can completely customize the machinery to roll specific profiles, and there's a whole bunch of other features available too. So knowing what operations are included in your machine and what they're used for is extremely important to your construction process. And most commercial machines out there, they use the following features, and keep in mind some of the terminology I'm using may be different from manufacturer to manufacturer, but the basic principle is the same. So dimple holes, you can see a couple of examples on your screen right now. These are punched and countersunk screw holes, and they are extremely important part of the roll forming process. They help align the connection points of the studs, as well as making fastening members together quick and painless. So there's already a pilot hole drilled in these, or punched in these, I should say. So driving your screw through is quite quick. It also keeps from crushing drywall over screw heads, as the countersunk holes do not allow the screw head to protrude much from the face of the stud wall. So then there's a swage. So if you look at the you know, the example here on the left, you'll see that if you're trying to fit in 2 similar or exactly the same profile shapes one into another, they won't work well. So what roll former manufacturers have come up with is the swage operation to achieve this. Swaging the metal at the connection points, what it does is it shrinks the web width enough to allow the swage member to fit neatly inside the receiving member. So this is typically used at stud ends, so for top and bottom tracks. However, it's also used in horizontal and diagonal connection points. And what this does is really do a nice job of keeping the wall, perfectly flat for receiving things like drywall and sheathing. So obviously, if we're fitting two C channel members into each other, we're going to need a lip cut. So it's an essential operation for connecting C channel studs. With one another. The lip cut is removed along the length of the lip for the receiving stud to allow the Swage member to properly be installed. Then you have a web notch. So on the right, you'll see there's a big gaping hole through the web of this member, and that allows to pass completely through, one member to pass completely through another. And it can also be fired in sequence to create large openings through things like bottom and top tracks for things like plumbing stacks and HVAC, for instance. So then you'll have a number of different service holes. So here's a different example, and web holes. So most machines are equipped with a few different flavors of service holes. They're placed on the web of the stud. They allow pass-throughs of conduit cable, plumbing, or even clips. And some machines also have smaller holes for bolts for end-to-end connections, or they'll have smaller, even smaller kind of pre-drilled punches for pilot screws or pilot holes. Finally, there's the print feature. Most machines are equipped with some kind of inkjet printing capability, and this is to label each member with the panel identification tags, as well as the member identification tags. This is extremely important feature. It helps your team easily identify parts, both in the shop and on the field. Most labels are also directional. So this helps to kind of accurately place the part on the panel table for assembly. If you know all your labels are to be facing up and starting at the left, going to the right, you know that which direction your member gets placed on the panel table very quickly. Okay, next we're going to move on. We're going to talk a bit about the controllers. So these are really the brains of the machine. And you can think of these as an intermediary between the software and the machine itself. The controllers are an important part of the puzzle, as their main function is to take the CNC source data from the design file and translate it to machine code or G code, telling the machine when to precisely fire each operation and to produce your stud and your panel ultimately. There are machine manufacturers that produce their own controller, and there are others who source controllers from third-party companies. But really, what you should be considered, what should be considered here, is the controller. Is it easy to use? Does it support the features I want to use in my business? And can it be upgraded to support those features? As technologies advance, the ability to connect to a remote server and remote monitoring of these controllers has become an important feature for some companies who wish to start to move their data to the cloud. So it's something else that's very important to think about. Can I connect via Wi-Fi or through a hardwire to our server, whether that be a remote server or an in-house server? So that's something just to think about. Next, we'll talk a bit about software. I'm not going to go too much into this. Clearly, I'm biased in my software choice, and I don't want to make this discussion a promotion piece of MWF, Onyx, or what we do. I'm also assuming at this point that most of you already know about what our software is and what it does, and considering other options is also a good thing. After all, a role former will likely outlast the usefulness of any one software, so this needs to be considered. So some important questions are, does the machine support the software currently used in my business process? Okay, you don't necessarily want to upend your complete business just to support this machine or vice versa. Is the software compatible with the design software used in our business and the businesses of the companies that we deal with? Now more and more, we're building using building information modeling systems. We're collaborating. We have MEP contractors, drywall contractors, structural services, and so on, all using the same kind of platforms. Does my software play with that? Can I take that information and quickly use it to derive my CNC output? Or do I need to completely redraw the project just to get my wall panels out? So it's something to think about. And then again, understanding that this machine is going to outlive the software. Can it be changed? Can it be adapted to new software? Something else is going to come out down the line that may be better or easier to use. Can I then run that on in my machine? So these are important things to keep in mind when we're talking about software. So basically, that being said, not all machines support all software and vice versa. We really need to kind of keep these things in mind through the process. So last, I want to go through some other considerations, and this is kind of the only part that I'm actually going to offer some opinions on the whole matter of roll formers. So if you're considering a machine, it's because you want to or you're already building off-site, I'm assuming. Now, this machine, once set up and running, it's going to become one of the single most important parts of your business process. Roll formers are in general extremely reliable, but like any machine, they require maintenance. They also require certain consumables from time to time, such as punches, shears, and other tools. So you need to know that in case of breakdown, that you can have access to the people who will quickly get your machine back up and running. It's the most important advice I can give anyone considering a roll former or any CNC machine for that matter. Will I be able to pick up the phone and get the parts and service and support that I need to keep my business running? Are the parts readily available, and do I trust the company and the people that I am working with to purchase this machine? If we think about this machine is going to be the one most important part of our building process. If it stops, my construction essentially stops. So we want to make sure that we limit this downtime as much as possible. And when it eventually does occur, how quickly can I get back up and running? Is this company reputable, or are they going to be able to support me? All right. Even if you're able to pick up a machine at pennies on the dollar, if you're not dealing with a reputable manufacturer, and if you can't trust that you can have access to top-notch service and support and parts whenever you require, then at some point your machine's going to be nothing but an expensive paperweight. I've seen it a couple of times over the years, probably more than a couple of times actually. Companies purchase used machines, secondhand machines from manufacturers that are no longer in business, machines that are kind of one-offs or off-market machines, off-brand machines. And they pick them up super cheap. They run them for a little while, that machine breaks down, and they are stuck. Their construction process is completely stopped. They don't know what to do. They can't get service. They can't get support. The machine literally just becomes, mothballed in the corner someplace, and they go ahead and they will then spend the money on a proper, well-manufactured, but more importantly, well-supported machine. So that's my number one, opinion about this whole thing of roll formers is think about who you're dealing business with and who in the long term will be able to support you and your business's growth, because essentially you will be looking at purchasing more machines. You will be looking at expanding, hopefully. So you want to be sure that you have a good enough relationship with these guys to keep things going. So with that said, I'm going to open everything up to questions. I don't want to get any questions about what machine I think is best, because I don't really have an opinion on that. I am very open to any questions regarding the technology and you know, if how that might fit into your current business process. So if there are any questions right now, I'm just going to take a look. You can also raise your hand if you want to ask a question live. I'll keep that open for another couple of seconds. Don't be shy, guys and girls. Can I explain swaging? Absolutely. So let me just go back to one of my slides. Let's see if this comes up. Give me a second. Let's see, guys. All right, swaging. Perfect. All right, so the swage is used as a part of the connection process. Every connection, it runs 3 or 4 different tools to simplify that connection. Okay, so if we look at the example on the left, we have 2 studs fitting into each other. Now, swaging is used primarily on single profile machines because you have 2 members that are exactly the same width trying to fit into each other. So you can force that, and what you're going to have is a bulge at that connection point. But with the swage, you don't need to do that. What the swage is going to do is it shrinks across the web here, the wide part of the stud. It shrinks that just enough so that the stud fits into the track. So there won't be any bulging. You don't have to force things in, and it just makes the process much easier. I think some manufacturers have also created a swage and a shear. So the shear is the cut, which act together to kind of crimps the ends, the very corners of the member, so that they fit into each other even better. This gives better stability, because you can imagine that if you don't have, if you're building a structural wall, for instance, and you're not exactly down on the inside of the web of the track member, then you're supporting everything off your screws. That eventually is not, that's not a very strong support. The screws eventually will start to bend and to tear the steel, because this is very thin steel, of course. So if it's completely down along there with the swage and the shear, then your stud is supporting itself. Hope that explains what a swage is. Are there any other questions? Excuse me. I have another one. Which are the most popular software that can also produce machine files for the roll formers? All right. So our company, Structsoft, produces MWF. That is definitely a a popular software. It's a Revit-based application that will produce the CNC file based off of a Revit model. We do have a few competitors in the market that do similar things. One of the main competitors in that market, there's, I think Tekla offers that as well for certain machines, as well as Vertex. So you're very welcome to investigate all of those. As I mentioned, I'm extremely biased and think we have the best solution. So back to the question to the swage. There's just specifying, so the track and stud could be the same width. Yes, exactly. That's exactly what's happening. The track and the stud are the same width, so the swage is required to shrink the end of that stud to fit into the same width track. All right. See if there's any other questions that are coming in. So do these software also have structural analysis design capability? Our software does, especially for like-age steel trusses, truss floors. It does have the design capability, but in general, a 100% total solution for like-age steel design and capacity does not exist. Some software offer, you know, kind of table-based design. We don't do that. We do actual analysis, finite element analysis, engine design, which is, you know, it's a more precise process. But again, a full building design solution that also does like-age steel, you know, shop drawings and CNC output does not exist. We are working towards it, though. It's kind of the long-term goal for our software. So there's another question that just came in. How much should I expect to spend for a single profile machine with swaging, punching, and labeling functions? It's a good question. I'm not a salesperson of these for these machines. From what I've heard from various customers, a single profile machine, depending on the size and depending on the gauge of material that you want to run, most of them run a number of different gauges. Those machines will run about 200,000-ish. I think you can find things depending on the on what you're you know looking for as far as features, a little bit less, a little bit more, but I think that gives you a good ballpark. There's a question about software pricing, which I'll answer over the email afterwards. I can get into that with you. And let me just see about hand raising. Nope, that looks to be it, guys. If there are any other questions, by all means, my email is attached to my username here. If you look at the audience, you should be able to find me. From there, you can ask me any of these questions. I know there's a few questions that are coming in last second, which I'll answer via email. It was a quick little webinar. Few questions answered. I hope everybody is a little bit more informed about roll formers and what they do, and better equipped to make you know, some business decisions after this webinar. Again, if you have any questions or you need any advice, feel free to reach out to me. You can reach me. My name is Brandon, and I'm available at info@struxoffsolutions.com. Thanks, and have a great day, everyone.